Ooh, it's getting exciting now. We're going to solve some trig equations in radian measure. So in the last video, we looked at solving trig equations in degree measure, which we're all pretty comfortable with. Radian measure takes a little bit of getting used to, but it's not so bad. The basic equivalency is that pi radians is 180 degrees. And it follows from that pi over 2 is going to be 90, and so on. And so these would be all the important ones to know. Just like when we were working with degrees, we're asking the question, what value of x is going to produce a sine of, say, -1/2? And we're actually going to solve all the same equations that we did in the last video, but only using radian measure. The steps are the same. We want to find the reference angle. We want to use ASTC to sketch. We want to determine each angle in standard position, and finally just write the solution. So let's get down to it. There are downloadable notes as well as a worksheet in the video description below. If you want to do the presentation along with me, just download them and print them out. Here we go. We want to solve sine x equals -1/2 for 0 to 2 pi. That's the same in degrees as 0 through 360. It means in the first revolution in standard position. So our steps are, number 1, find the reference angle. Where is sine going to be? Forget about the negative. Where is sine going to be a half? It's at 30 degrees or pi over 6. And if you want to think about degrees at this point, that's fine. But it's helpful to start to become, I guess, fluent in working in radians. Okay, number 2, figure out what quadrants we're really in. So notice here, sine is negative. Where is sine negative? In quadrant 3 and quadrant 4. Let's sketch. So I'm going to draw an angle of pi over 6, which I know is 30 degrees, in each of these quadrants. And if you're not very familiar with radian measure, this is the part where it may be a little bit, I guess, take a little bit of extra work. So let's think about this. If I want to find that first angle, I'm going to go those 180 degrees, which is pi radians, plus another pi over 6. So I have pi plus pi over 6. That's my angle. Okay? Which is the same as, convert to a common denominator, 6 pi over 6 plus pi over 6. Okay, 1 pi would be 6 pi over 6. That gives us our first solution, 7 pi over 6, which corresponds to 210 degrees. Let's do the other one. If I wanted to find this one, it would be like a full revolution minus that pi over 6. And a full revolution is 2 pi. Okay, if I think that one through with a common denominator, 2 pi would be 12 pi over 6 minus a pi over 6. Or, as a final answer, 11 pi over 6. Those are our angles in radian measure that satisfy this equation. Okay, so all that we needed to do was do a little bit of work with common denominators. Now let's see if it really works in the original equation. I'm pulling up my calculator here. I'm going to turn it on. I'm going to make sure that I'm in radian measure. Okay, good. And I'm going to check this out. If I press sine of 7 pi divided by 6, I really hope that's going to give me -1/2. And it does. That means that value actually balances the equation, or that angle. Let's try it with 11 pi over 6. Very nice. So we know that it's right. Those are our two angles. If we were to convert them to degrees, we'd find they're the same answers that we found in the last presentation. So that was step 4, was to write our final solutions. Let's try it with another one. So cos of root 3 over 2. Find the reference angle. Where is cosine root 3 over 2? Just go over. Hey, look at that. It happens to be at pi over 6 again. That doesn't mean that all our answers will be the same. So that's step 1. Step 2, think about ASTC. Okay, and in this case, cosine is positive. It's going to be positive in the quadrant where they're all positive and where cosine is positive. So this was a positive. Now let's sketch. So I need to draw pi over 6 in quadrants 1 and 4. That first angle is really easy for us to find. It's just pi over 6. The second one, I would think of it this way. It's a full revolution minus that pi over 6. Or it's 2 pi minus the pi over 6. Okay? And 2 pi is 12 pi over 6 minus the pi over 6. 12 over 6 is the number 2. Meaning that our second solution is going to be 11 pi over 6. 12 minus 1 pi, 12 pi minus 1 pi would be 11 pi. Those are our two values that should give us a cosine of positive root 3 over 2. And again, if you threw them in your calculator, it would confirm that. Might give them to you in decimal version, but it would confirm what we expect here. Let's do another one. Tan x is negative 1. And hopefully at this point you're getting the idea that it's always the same business. Find the reference angle. Tan is 1 right here at pi over 4. Think about what quadrant. Tan is negative. Where is it negative? It's negative here and here. It's positive in the other two. Okay, now let's draw that reference angle. So pi over 4 right here, and pi over 4 in quadrant 4. Finally, find those in standard position. So I would think of this first one as pi minus pi over 4. It's pi over 4 less than pi, or 180 degrees. Okay? And you would think of that as, well, that's 4 pi over 4 minus pi over 4. Giving us that first solution of 3 pi over 4. And it does look like that, that size angle, like 135 degrees. Let's do the other one. It would be like a full revolution minus that pi over 4. Or 2 pi minus the pi over 4. Okay, now think of it common denominator. 2 pi would turn into 8 pi over 4 minus pi over 4. Hey, second solution is going to be 7 pi over 4. Okay, so there's just that extra little step of finding a common denominator. Remember that half a revolution is pi, and a full revolution is 2 pi. Let's do one last one. Sine x is negative 1. And again, this is just in the first revolution. So, same process. Theta ref. Where is sine 1? Hey, sine is 1 at 90 degrees, or pi over 2. Sine is negative here. So where is sine negative? In quadrants 3 and 4. Step 3, sketch. So remembering that pi over 2 is 90 degrees, pi over 2 looks like this in quadrant 3, and like this from quadrant 4. It turns into the same angle. And you can find the value of that angle by either going 180 plus 90, or pi plus pi over 2. Okay, common denominator means that's 2 pi over 2 plus pi over 2. Or you could think of it as a full revolution minus pi over 2. So 2 pi minus pi over 2, which would have been 4 pi over 2 minus pi over 2. Any way you slice it, we're going to have an answer of 3 pi over 2, which is 270 degrees and does look like that angle. Let's make sure it actually works. Sine of 3 pi over 2. I'm feeling lucky here. Oh yeah, we get -1. So now we can solve equations in radian measure in the first revolution for exact solutions for any numbers that are actually in that table. And in the trig equation 0 video, we go through how to develop that table. Next up, we're looking at approximate solutions. See you soon.